Okay, so there might be a few different ways to work with um, the quotient of two functions. So I want to look at the limit as z goes to z0 of, say f over g, and I want to say that that's equal to some big F over g like that. If g is not equal to 0, and we have that the limit as z goes to z0 of f is big F, and the limit of z0, I said 0 instead, limit as z goes to z0 of g is big G. So there are a few ways to do this. One way could actually be just work with the limit of 1 over g. Um, and let's try that, because if I show that the limit of 1 over g, little g, is 1 over big G in this situation, then I can just use the product uh, rule of limits, not of differentiation, to do this. So let's look at that. Let's look at the limit as z goes to z0 of 1 over g of z uh, equals 1 over g. And so we start that, I'll start with 1 over g of z minus 1 over g. Okay, well, I'm going to get a common denominator, because when I do that, I get this nice g minus g of z all over g and g of z like that. So, I get this thing here, and the top is exactly what I want, because I know I can make that less than epsilon. Usually we'd write it as small g minus big G, but it's an absolute value, so it doesn't really matter. So I noticed that, the top, I can make less than epsilon, but now I'm going to get fancy with that. I'm going to choose a slightly different number than epsilon, and the number I'm going to pick is actually what? Epsilon times g squared over 2. So I can make the top that small given the right delta. Okay, and again, I'm just picking a number, but I'm going to call it epsilon times g squared over 2. And the reason I'm going to do that is, well, so I know this is less than the absolute value of g minus g of z divided by the absolute value of g minus the absolute value of g like that. Now, and back here, I better call this given delta 1. And then what I can say from the previous video corollary is that this is less than or equal to, and I'm going to write it now as my g of z minus g, because I just like the looks of that better, divided by that g. And then I can, not less than or equal, but less than, this 1 over g of z, I can say is less than 2 over big G. Okay, that was from the previous video, that corollary. And so now, what I have is this is 2 over the absolute value of g squared. And there I have my g of z minus g. Now, but I only get to say this given some delta 2. I have to be within delta 2. Now, I don't know which one of those is bigger or smaller. Okay, but I know that if I'm within delta 2 from that corollary, I can replace my 1 over g of z with 2 over big G. And so then, as long as I pick the smaller of these two when faced with that, then this is less than 2 over big G squared, and then I'll use my epsilon that I had up here, which was, and I didn't have absolute values on that. My epsilon of G squared over 2, okay, and this is delta equal the minimum of delta 1 and delta 2. So I don't know what that is, but you see it's all in theory anyway. And so those cancel out and I get my pretty epsilon. So, in math we often tend to do this kind of stuff, like choosing this epsilon to be not so pretty, so that when we get to this one, it is pretty. Everything cancels out and it looks nice. Okay, so that tells me then that this limit is true as long as g is not equal to 0. Okay, so I have that. And so now I know that the limit as z goes to z0 of f of z over g of z is equal to that f over g by product, okay, of f of z and 1 over g of z. Okay, so there I kind of tricked it into being a product rule. Now, that all said, I'm not going to go through this whole thing, but instead of doing it as a product that way, you could kind of get at that same place. You need pretty much that same corollary about the size on G or 1 over G and all that, but instead you could look at, whoops, I don't want the limit here. I just want to start with my f of z over g of z, just like that, minus f over g. And if I get a common denominator, I'll have f, and I'm just going to make it abbreviated there as f, and so f of z, g minus g times f over g times big G. Okay, so I could do that, and then I can introduce f big G and then minus f big G and plus f big G and then minus little gf. So I add and subtract the same thing there, all over G, like that. And so then what I get to is I get that I want to work with and that. So I use again the triangle inequality. So this is less than the absolute value of. Now I'll have a uppercase G in both of those and uppercase G there. So actually this one I'll have F minus F over G like that. And then plus, and this other one, I'll have F over G and big G. You know, nothing cancels nicely there, but it doesn't matter because I'll turn all of that into numbers, and then the G minus little g. Okay, so again, it's that same sort of thing. You have to say that can get, you won't get too big, and the same thing with that little g there. That's so you'll still have to use that 2 over the absolute value of big G thing. But you know, you get to use the here, knowing that limit, I can get an epsilon. Knowing that has a limit, you know, or will be less than epsilon, I can make that less than epsilon. And so you see I get some number times that epsilon, some number times that epsilon. That's basically an epsilon. Now, the finesse and the nice writing and so forth is to pick that in a form that will cancel out with that, and pick that one in a form that will cancel out with all that stuff, to make it very pretty to get to epsilon. But so you can start from here and just use the triangle inequality, and you can get to that same result of showing that limit exists. And the bottom line is you still need to bound 1 over the absolute value of little g, and that's a key. So in this case, for this particular approach, instead of 2 deltas that I'll have to come up with, I'll have to come up with 3, because I'll have a delta for the g here, I'll have a delta for this particular epsilon thing that I do, and I'll have a delta for this one. So I'll have a delta 1, 2, and 3 for those. Okay, but that's the idea, and these all are kind of done basically that same way. You practice them a lot, and you get better at them. Used to the idea and so forth, but yeah, that is our limit of f over g.